Good evening, everyone. Uh, I hope you are doing great and a warm welcome to this bootcamp. Hello, good evening. Okay, so let me introduce myself. My name is Aishwaryaanjali and I am from Visakhapatnam. I'm currently studying my final year of computer science engineering at GVP CEW. So I work with Nexus Farm. Um, Here I work as a video editor and sometimes as a graphic designer. So that's a little bit about me. I'm really excited to be with you all and start this bootcamp with you. So before I jump into this bootcamp, let's just make it a little interactive. Can you all quickly tell me how many of you are attending your very first boot camp? Please put in the comment box if this is your first boot camp. Okay, great. I'm seeing a quite few. So may I know which city are you joining from? Okay, Mangalore, Delhi, Visakhapatnam, Delhi, Kurnool, Hyderabad. Okay, okay, we are having so many places. So I think are you all students or are there any working people? Students. Okay. I think all of you are students. Okay. So, how many of you have already have some idea about machine learning, or else are you absolute beginners, or you have at least a little bit idea on machine learning? Okay, some of you have little idea, and some are absolute beginners. So, I think all of you are engineering students only, right? Are there any other people, any other course domain people? All of you are computer science engineering students. Okay, then, okay. Okay, we have an MCA student. Okay. Okay. So, I think let us start this session. Are you guys ready? Are you guys ready? If yes, put yes in the chat box. Yes, okay. Okay. So let us start the session then. Um, so I will ask you a very simple question. I think oh wait a minute. Okay. I think all of you are familiar with these kind of questions, right? Can you see the slide? I think all of you are familiar with these kind of questions or like puzzles. Yes or no? Like you might have seen these in some kind of like some in newspapers or social media. Okay, okay, okay. I think okay. So this is a very easy question. What does this question mark replace? Put your answers in the chat box. Okay, okay. Some are commenting 5. Yes. So it's 5. There is no need to explain it, right? It is a very simple question. Yes, 5 B's. Okay, some are putting it as 5 B's. Okay. Now answer this question. I'll give you another question. Answer this one. What does this question mark replace? Yes, it's plus. I think there is no need to explain this also, right? Yes or no? But we'll analyze. Okay, we'll analyze what we actually did here, and how is this? How is these kind of questions are relevant to us right now? Like, what is the use of this question? Okay. Um, First, let us look at this question. So here it says 3 plus 2. The first part says 3 plus 2 equals to, we have here a question mark. And what is this? You were given two numbers, 3 and 2, and the operation is already known, right? It's addition. Yes or no? We know the operation and we already know how this operation works. So you just applied the rule you already know to get the answer. Yes or no? We just applied the rule. Here, the rule is known and answer is calculated. We know how addition works, right? Uh, 3 in one hand. After that, we'll count 1, 4, and 5. So you'll get the answer as 5. Yes or no? We already know how this works. So you just applied the rule. So this is nothing but this is exactly how traditional programming works. Like we or like the coders or programmers, we write program, right? Program is nothing but like this specific step by step instructions that tells the computer how what to do, like what tasks to be performed. So basically we are writing some rules, then the computer just applies the rule to get the answer. Yes or no? So the rule is known, then we apply the rule, and the answer is calculated. This is nothing but the traditional programming. Now look at the other question. We have here 3 question mark 2 equals to 5. Yes or no? Here the answer is given, but the operation is unknown. Yeah, right? Here the answer is given, but the operation is not unknown. we know that there is some kind of operation, like we have some data, and we know some kind of operation is being performed. We have the input, we have the output, but we don't know what is happening there. So um, you have to figure out which operation satisfies this condition. Like you would have checked, right? If I give you a big number, you would have put plus, you would have put minus, or multiplication, or division, and you would have checked, right? Yes or no? We know we are figuring out the operation. So here the answer is known and rule is learned. And this is exactly how machine learning works. We give the computer a bunch of examples along with inputs and outputs. The computer then learns the rules from the data and it will tell us the rule. So that is the basic idea behind machine learning. The answer is known and the rule is learned. So I think now you guys understood what is machine learning, right? Like you had some basic idea. You got some basic idea, right? If so, put yes. Okay, understood. Um, so machine learning is like we know the input and we know the output, but we don't know what kind of process is being performed on that input led to this output. Yes. So we give the computer, sorry, we give the data to computer and computer figure out the rule. So this is what is machine learning. We learn the definition, like the definition and all, but firstly, um, okay, there is this term buzzing everywhere these days. You have probably heard it in news or apps, social media. Yes or no? You guys are all, some of you guys are also using it daily. Can you tell me what it is? That term that is buzzing everywhere. Yes, okay, artificial intelligence, AI, AI. Okay, exactly, exactly. That's artificial intelligence. That's the buzzword everyone, literally everyone around us are talking about. So let's break it down clearly. So we'll understand these terms. What are about these terms? What is AI? What is ML? We'll understand what these buzzwords mean. Okay. So firstly, you can see as in the PPT, AI is AI. So basically, AI is a field where computers are designed to perform tasks. Like tasks that require human intelligence. Okay, they are simply AI is nothing but some computer systems mimicking human beings. It's like the computer is acting like human, like the machines, they think, the reason, they solve the problems. I think most of us are using chat gpt, right? You might understand what is AI. That is simply an AI. It acts like human. It thinks like human. It acts like human. It gives responses like human. That's what ChatGPT does. So this is what AI is. And the next slide, I will go. What is machine learning? Machine learning is subset of AI. Machine learning itself is an AI, but it is it is a field. It is a subset of AI where the computers learn from data. Now, whatever we did before, also we could find the pattern on our own, right? Yes or no? We could find our pattern on our own. That's what machine learning also does. Like we previously know what addition does, or we previously know how certain output comes when there is certain input. we have a little bit idea, because I think from our childhood we are doing those basic math problems, so we have an idea, right? So we learned from the examples, we learned from those examples. In the same way, machine learning also, for the computer, for the system, we give some examples. Okay, we give some examples, and from those examples it will understand some pattern, it learns some pattern, it will learn from that data. And then it can like for new data, it can understand that one also, and it can figure out what to do. Yes, and that's what machine learning can also do. Like in the before example, for two question mark three question mark two somewhat, uh, so they if we give if we give some before examples, maybe like 1 plus 2 equals to 3, 3 plus 4 equals to 7, if we give these kind of examples to the computer, then the computer can figure out itself that 2 question mark 3 equals to 5. It can understand, okay, the question mark replaces plus. So based on those examples, the machine learning can understand. And machine learning applications are everywhere nowadays. Like there's so many examples, and I will discuss about those in the further session. And we learn the next one is deep learning. So deep learning is subset of ML. Here deep learning, you can think of it as like deep learning is nothing but it's like more powerful version of machine learning. It uses something called neural networks, okay, which are inspired by human brain. They are inspired by human brain to learn very complex patterns. Like in our brain, I think some of you might have an idea. Like we have neurons, and those neurons, they'll take input signals, they'll process them, and like then we'll get some output. Like for suppose for like that's how human brain works. And similarly, in a neural network also, they mimic the neurons. Like there is something called artificial neurons. Those take the input, they'll do some kind of calculations, and they'll give it to the next layer. Okay, so these neurons are all connected, and each the input or the data will pass through each neuron, and the computer can learn and recognize complex patterns, like how our brain does, how we can see images, how we can understand like facial recognition or whatever these kind of things. How we can understand. uh, in the same way, computers can also understand based on the neural networks. This is what deep learning does. So they can, why neural networks, they can learn very complex patterns from huge amounts of data. Like at some time, machine learning cannot do all that work. Like DL can handle massive amounts of data and complex patterns, all those things, and learn from it in a ways that regular machine learning cannot do it. So this is very complex stuff. But for this boot camp, we'll learn about machine learning. Okay, so I think now you understood, right? What is AI? AI is like a broad field of like computers that can mimic human intelligence. And in machine learning, AI learns from the data. Machine learning is a subset of AI where machines learn from data. And then we have deep learning, where the machine where the ML, it is subset of ML, and it learns from neural networks, like complex patterns. It can learn complex patterns from neural networks. I think you understood what is AI, ML, and DL. Okay. So next, so what actually machine learning is? I mean, I think you guys understood what actually machine learning is, but let us look at a definition which was given way back in 1959 by Arthur Samuel. You can see here. So now let us look at how it is defined by Arthur Samuel. He said a field of study that gives computers the ability to learn without being explicitly programmed. So what does that mean? Like we needn't write any special program for it to understand. We have to just write a small code to take for it to take the input and then process it and display the output. That's it. It can learn on its own. The computer can learn on its own. That's what machine learning is. There is no need to explicitly program something. As we discussed before, in traditional programming, we give the rules and the computer just follows them. But in machine learning, what did we say? Instead of rules, we give the computer data and some like data in form of input and output, and it learns the rules on its own. So that's what the definition says. There is no need of traditional programming. There is no need of us giving rules to the computer. The machine itself can figure out the rules based on the input and output. So, so, so this definition was actually, I think, almost it's been 60 years, but still, this is how exactly machine learning works, and this is still, it still perfectly matches how machine learning works today. So, to understand this definition better, I'll show you an example. Okay, I think then it will be easy for you. Okay, let us look at this example. So, okay, let us look at this example to understand how a machine can learn. So, here, see the first box. In the first box, you can see, okay, congratulations, you have won some 10 lakhs, and dear user, you are lucky winner of a cash prize. Something is there, right? Click the link below. There is some suspicious link, and also there it says some offer expires and all. So I think you guys might be familiar of spam mails, right? I think all of you have mails, and you can know the difference between spam and not spam, right? Okay, so see, we can understand this as a spam mail, and so I mean, okay, this is the data which we'll give to the computer, and all these are labeled. I mean, they already have output. I'll tell you about labeled and all later on. So this data is, we know the input, we know the output. So we are giving this to the computer, and when we give a fresh email, it will predict, or it will detect whether it is a spam email or not a spam email. So we'll give these examples to the machine. Okay. Uh, we have some more emails also here. Like there is some. Wait, 1 minute. Okay, we have here. We have here meeting reminder, project update, and I think we can understand that is between two employees, right? Some employee Sarah. Okay, someone named David kept a mail to Sarah, and we can understand. Okay, this is a work email, and this is not a spam email. Yes or no? And then we have another one. Okay, you have been selected. Claim now, and we can understand there is here also there are some link. It says click here. All these things we can understand. This is also spam email. Then we have few other emails also, not spam and spam. See here it says congratulations. Click below. Offer expires. All these things. So So when we give this to the machine, it will see all the spam mails first. Like it will see all the spam mails, and it will take common phrases or those kind of things that contribute for a spam email. Like it will recognize the patterns that mean they are spam emails. Like for suppose there are some things like congratulations or suspicious links or claim now, hooray, something, these kind of things, they often contribute to spam emails. Okay. It will also check non-spam emails also, like it looks for patterns like report or bill, meeting, or those kind of things. They are generally not non-spam because they are maybe work related things, so we can understand they are non-spam, and this can be spam. It will check these also. In this way, it will see what kind of patterns spam emails follow and what kind of patterns non-spam emails follow. And then after learning from these examples, when we give now when we give a fresh new email, it can predict whether it is spam or not. Okay, it can predict whether it is spam or not. So in this way, it can learn. I mean, the machine can learn the pattern, and then easily it can classify. So in short, the machine learns from the data which we give, like the input. I mean, the date examples. Maybe you can say it as examples. Then it can handle new inputs on its own. So this is how exactly machine learning works. It figures out the rule by observing the data which we give. Okay, I think all of you guys understood this example. Did you guys understand this example? Okay. Is there any confusion till now, or is it fine? Did you guys understand? Okay, it's absolutely fine. Okay. All right. Now, let me explain why. Okay. Now you guys may have doubt. Okay. For if this is recognizing some patterns, maybe we can simply put some if else conditions. We can use the traditional programming, right? Like we can put if congratulations is there in the email, or if claim now, click now. Some, if you can put some, like you might have this doubt, right? Right, like we can put some if else conditions, and then simply we can detect, right, whether the mail is spam, which type of patterns. Give some example. Like as I said, Rani, as I said, it will recognize the words. I mean, it will recognize the words like claim. Now you can see in this example, um you can see in the first example there is congratulations, and there is some suspicious link or claim now, or claim your money, some link, click now, offer expires in 24 hours. There are these kind of things, right? Generally those kind of things will not be there in a nice spam, like a normal mail. There some, see, you can also see some emojis. Like if there is something professional thing, we don't use emojis, right? It will see these kind of things. I mean, it will take all the spam emails, like based on the data which we give to the machine, it will recognize the patterns. Like in, if you see properly in these spam mails, you can see those words being common, right? So based, because of these, it will recognize the common phrases in the spam emails. In the example we gave, the machine will recognize. You can see here claim now is, claim is there, or some suspicious links are there. Those kind of phrases, they will be considered as the spam. Okay, they will be considered as spam, and the machine will see the new fresh email, and it will see, okay, if these kind of words are there, then it will recognize as spam. uh, did you understood? Did you understand, Rani? Okay. um, if you have any doubts, guys, you can ask me. You can ask in the comment box, and I'll try to reply. Okay. Okay, what I was saying. Yeah, okay. I was saying, okay, why we can write if else conditions, right? We can write if else conditions, and then we can simply write some big code, and we can easily detect which mail is spam email, which mail is not a spam, not a spam email. But that is very difficult. Maybe for few tasks, maybe you can write like that, but we cannot really depend on rule based. I'll tell you with an very nice story. Okay, maybe like an analogy or something, not a story. Okay, so imagine. Okay, yeah, these Rani, these kind of things, it will recognize these kind of things, and you'll you'll know which is a spam email and which is not a spam email. Okay, now, so why machine learning instead of rule based? We'll see that. So let us imagine we have a robo chef with us. We have a robo chef with us, and so obviously, what a chef does, cook, right? So I have written some recipes and I gave them all to the robo. So there are many recipes, right? I gave him pasta, pizza, or even biryani. I gave him so many recipes. But I asked him to cook Maggie. I also gave the Maggie recipe. So I asked them cook to the robot chef. Okay, the robot chef to cook Maggie, and he did it, and I ate. But the next day, I wanted, like some soupy Maggie. So firstly, basically how this works, I will give step by step instructions, right? For a traditional based model, or like traditional based robo, I'll give step by step instructions. I'll say how to cook Maggie, like boil 1 cup of water, add the noodles, add the taste maker, cook for 2 minutes. I'll say all those things, right? I'll say all those things. And now the robo will follow them step by step, step by step. It will follow it step by step. So the next day when I ask him, okay, can you cook now? I want it very soupy. Now the robo will not understand it because it will make the same Maggie recipe. If it is using 1 cup of water, it is just a normal way, and I don't like it right now because I want something soupy. I want my Maggie soupy, but it cannot understand. So the RoboChef will have no idea at all because it can only make the exact recipe which we give. So what do we do now? We have to add a new rule. So I'll open the robo, I'll write a code. If the user says, soupy, you should add 1 more cup of water or something like that. I have to add a new rule. But again, the next day I was like, I want it like cheesy or creamy or something. And then I should say, okay, you should also add cheese. Again, I should put a rule. If the user says creamy or cheesy or something, you have to add cheese. I have to say something like, I have to put a new rule like that all the time. So I think most of us we'll have different versions of Maggie, right? Everyone cooks in different way. So we have so many tastes, right? So we have to add so many if else conditions. If we want the diversity, we have to add so many if else conditions, right? um so So if you know, now you might think, okay, if we just keep adding enough if else conditions, then the problem will be solved, right? No, like there's so many variations. Like some people might want to add some vegetables, or some people want less salt, or like cheese or buttery, something like that. They want healthier versions. So writing a rule for every possible case is very difficult, right? It is very, very, very difficult. You have to write so many rules, and it is very tiring also. So that's where the machine learning robo will come. See, now this now we have a ML robo. Let us assume we have a ML robo chef. So instead of programming rules, what we have to do is, we have to show the robo so many Maggie recipes, or not so many, maybe a couple of them, maybe a couple of them with a little varieties. Then maybe like, okay, Maggie, oh, a soupy Maggie will be like, you have to add some extra amount of water. A dry Maggie is like, you don't need to add some, you don't need to add like 1 cup of water, you can add a little less. If somebody says they want spicy, then like spicy Maggie is like, you have to add extra chili powder or something. We can show few recipes to the ML model. The ML robo will not actually wait. The ML robo will not recognize these recipes. It will not recognize the recipes. It will just learn the patterns. Like, as I said, somebody, if I show it a soupy Maggie, then it will understand, okay, more water means soupy Maggie. Chili powder, if we add chili powder, then it is spicy Maggie. Like the Maggie becomes spicy. Or if like if cheese is added, then the Maggie becomes creamy. Something like this. The machine learning will understand patterns like this. Okay. So over time, the ML robochef will understand, okay, what changes are these? Or what kind of changes will make the Maggie so and so. So when I go and say, okay, I want a Maggie with a cheesy Maggie, but it should be very spicy, very cheesy, something like that. If I say, even though the recipe for that is that food is for that type of Maggie is not there, the ML robo can instantly understand, it can adapt, and it can prepare for us. Like without I needn't even write the rule. Like, okay, I said no cheesy, right? I want another slice of cheese, or I want another spoon of chili powder. I needn't even write those rules. It can instantly adapt based on the previous recipes. So that is the big difference between traditional based robo and a machine learning based robo. The traditional rule based robo, it follows the fixed instructions, and for any new requirements, we have to add more rules. But for ML robo, it will easily understand the examples, and it adapts to the new requests without us writing any kind of new rules. So that's why, like in today's world, the technology is changing very quickly, and so many new things are coming, and data is becoming so huge and complex. So it is a very good like it is a this is a time when machine learning is useful. Machine learning, it will be more powerful than writing like endless amounts of if and else cases, if and else rules. So I think now you understood why machine learning is becoming very important these days. Okay, like not just for this thing, like for anything, machine learning is very important. I think you can understand based on this example. Did you understand why machine learning is okay? Okay, so not okay, not just some Maggie. I just gave you guys some random example so that you can understand. uh, now let us see why machine learning is useful. Okay, now let us discuss with some real world examples. There's so many real world examples, and we'll look at few of them today. Okay, so yeah, these are okay. I forgot to tell. These are four superpowers of ML. I think you can understand why it learns from experience, as I said about the Maggie recipe, and also it adapts to change. It finds patterns human miss. Yes, this point comes when we deal with big data, like when we are dealing with large amounts of data, and it works at superhuman speed. Obviously, we know machines work very fast. So these are like four random superpowers of machine learning. Okay, yeah. Now let us discuss some real world examples. So the first one is email spam detection. As I gave you the example before, so we already learned this email example, right? So it looks at thousands of emails that are already marked as spam or not spam. Okay, based on this based on this, it will learn the patterns, as I said before, right? I think you guys understood, like winner or prize or click now or claim now, like this. It will recognize those patterns, and it will understand which is spam or which is not spam. That is email spam detection. And then we have Netflix recommendations. Machine learning, what happens is machine learning studies what kind of movies or shows you watch. Okay, the user activity is saved, right? So if you watch a lot of action movies, it understands your preference. It understands your preference, and then it compares you with your behavior, your watch behavior, with millions of other users, and finds similar patterns. Like for example, you watched Bahubali movie, then it might give you in after the movie it might give you recommendations like Bahubali 2 or RRR or something like that, because those are similar kind of movies, right? Like how users watch. Because it will see what other movies did the users who already watched Bahubali saw, and based on that the Netflix recommends movies or shows that you are most likely to enjoy. Yes or no? Like that, according to your preference, it will give you the movies. Okay, and the next example we have is self-driving cars. So like self-driving cars, they have dash cams, or like cameras, sensors. They collect the data from road. They collect the data from road, and the machine learning processes this data and learns how to recognize roads or traffic signs or pedestrians or any other vehicles that are parked or coming, or something like this. Using this kind of data, the car can make safe driving decisions, like automatically, obviously automatically. Like like for suppose stopping at a red light, or some pedestrian is walking, then it will stop, or when green signal is there, it will move. So these kind of things, it will take the data from the cameras, dash cams and all, and then it will give the decision. Okay, and one more example, I think this is very popular example. Most of us also use this, right? Like when we are locking our phones, we use those biometrics and all. So machine learning is trained on many images of faces. It learns unique features like the distance between the eyes, or like the shape of nose, the structure of jaw, the outline of our face. Like this, it learns all these things, and once it learns all these kind of patterns, it can recognize or verify accurately. Okay, so when we lock our phone, when we show our face, it will calculate, like do all these things. And even if we are unlocking our phone or on, like for suppose maybe outside or somewhere also with different lighting or with different maybe background or something, like we are not showing the same image, but how is it detecting it is us? Because it is not like storing the image, it is just storing the features of our face. It is storing the distance, maybe the distance between the eyes, as I said, the structure of the jaw, these kind of things. It is storing these kind of things. That's why when you are when you're even unlocking your phone with different background or different dress, maybe different hairstyle or something like that, also it can understand, okay, it is us and we are unlocking our face. So that's how our phone unlocks when we look at it. And another example is chatbots. Chatbots are like Siri, Alexa, or some support bots. I think you might be familiar with support bots or like help bots in some websites. These systems are, these systems are trained on very, very massive, humongous amounts of conversational data, like the conversations. Okay, they learn how people ask questions and what kind of answers make sense, how they can like satisfy the human with what kind of response, like what kind of response will human like. So when you ask a chatbot something, uh, something, it can understand your question and give a natural response like a human being. Like it's almost like you're talking like to a human assistant, right? It will try to mimic the human. Okay, so that is what a chatbot does. So these are some of the real world examples of machine learning. So as you can see, uh, machine learning is very useful, right? It's already all around us, like in so many forms, maybe in our inbox, in our phones it is there, it is in there in our entertainment apps, and even on roads, the self-driving cars, etc. So these are some of the examples of ML, and I think now you can understand how machine learning is making our lives easier. Okay. Okay. So now, um, now let us talk about the different types of machine learning. Okay, machine learning is usually divided into three main types, as you can see in the slide: supervised learning, unsupervised learning, and reinforcement learning. Okay, don't worry at all if these terms are like very big or like they're very complex or something. I'll just tell you, I'll just introduce these today. I'll just tell just a small introduction about these, and in upcoming session, like we'll deal with one type each day. Okay, one type each day, so we can easily understand what these are. I'll just give a small introduction about these. Okay, guys. Okay, now before we jump into the three types of machine learning, let us understand something very important. It's very important. You need to understand this. What is labeled data and what is unlabeled data? So, see here. I have some bees. I have some pictures, right? Like there is a bee picture, there is a honey picture, there is again a bee picture, and a honey picture, right? But they see, if the picture already has a name written, like name, like there is a name for it. See, for this first picture it is written as bee, the next is written as honey, so these pictures are already named. Yes or no? This is called label data. Okay, this is called label data. For each input we are giving the label. Okay, this is what is labeled data. The computer can look at the input and see, uh, see the correct output, which is B. So it is seeing the label, that is, those are known as labels. So it will see the label, and it can do the processing and all. I'll explain that to you. So I'm just telling you, this kind of data is labeled data. But if I just give you the pictures like without any names, if I just give you the random pictures without, they don't have any names, then that is unlabeled data. Okay, that is unlabeled data. The computer only has inputs and they don't have any outputs. Okay, right now if we give the if we give to the computer, it has only inputs, right? So it has to figure something on own. Like it will maybe see the patterns and it will just form a group. It cannot give an output. Actually, I'll tell about it in a clear way. We'll see how the machine or computer can deal with this kind of unlabeled data. So did you guys understand what is unlabeled data and unlabeled data? Okay. So, yeah, we'll go back. We'll learn what are those types. I'll just introduce them. So we learned label data, right? So in supervised learning, uh, the model gets trained on label data. Okay, the model gets trained on label data. So if we are giving input along with the output to the machine, then that is nothing but supervised machine learning. Okay, supervised machine learning. There are actually two types of problems which, like, in machine learning, two types: classification and regression. I'll tell you what those are. So in classification, it is like we are detecting the categories. Okay. uh, what we did before spam detection, we discussed, right? We discussed about this example, spam detection, right? So it is categorizing the data, like the fresh data which we give, into spam or not spam. Okay. It learns the patterns, and when we give a new email, it can predict whether it is spam or not. We are categorizing. This is classification. Okay. Classification means, like, we are dividing it into categories. Okay. Regression, that is, this is another kind of thing. Yeah, okay. Predicting next value. Okay. Predicting the next value. A very very easy basic example is weather prediction. Okay. Weather prediction is a regression task. Means, for suppose today it is like 30 degrees, tomorrow it is 32, a day before, like yesterday it is 28, something like that. And based on these values, you can find what is the temperature on day before tomorrow. Yes or no? I mean, yes. Like, we can detect the computer can detect the pattern, and it can predict what is the next value. So this is regression. Here we are predicting the next value, or like some value. We are predicting a value in the pattern. And classification is we are finding what category it belongs to. Uh, did you guys understood the difference between classification and regression? If so, put yes in the chat box. Okay. Okay, we'll understand about classification and regression deeply in the next sessions, but I'll just show you a little diagram. So you can see here, right? There is bee, honey, like bee. This is label data. You can understand, right? This is label data. We are giving this to our supervised learning model, like classification model. It is, this process is called training, like giving the input. Training means we are giving the input to the model, and the model is, trying to understand the pattern. I just said it in a simple way, but this is what training means. It will train on these models. It will see, sorry, train on the data. It will see the data, and it will understand the pattern. This is what is training means. So, and yeah, this is the one that is there on the left side is what we give for training. Now after our model is built, we are giving this one, the below one, the middle one, that we are giving it to the model. That is the new input. We are giving that as a new input. Now, you can see here towards the right side, after predicting, it is there are it is as it recognizes the images, right? This one as bee and this one as honey, right? So, like, how for male detection, how did it identify the pattern? Here also it will identify the patterns, and for the fresh pictures it will classify it. Okay, that's what happens in classification. I just gave you a simple example. Now we'll see regression. Uh, these dots, these little orange colored dots, these are, let us suppose these are the inputs, and based on this line, okay, based on this line, it will predict what is the next value. Okay, it will predict what is the next value. I'll explain this to you guys in very deeply, because we learn about classification and regression in the next days. In day 2 and day 3 we'll learn about them. You can easily understand. Right now I'm just giving you the introduction. Okay, and then we have unsupervised learning. Here in unsupervised learning, we don't give the computer the answers, like I mean the output, sorry, not the answers. We don't give them output, like what output will be there. That means we are giving unlabeled data. That's it, we are giving unlabeled data. So here we have one type of problem, which is clustering. Okay, which is clustering. So for suppose, see in this example, you can see the sweet box, right? In this sweet box, you have some white color sweet here and white color sweet here. We don't know what kind of sweet it is. We don't know the name of that sweet. Maybe it's a chocolate or whatever. We don't know what kind of sweet or chocolate it is, but we know the white one in the, I think, in the first column, last row, first column, in the second row, third one, those two are white colored sweets. They both are same, we know they both are same, but we don't know what is the name, or no, what is the name of it, right? So that's what machine learning also does. Like, when it doesn't know the name, it will just take all the similar ones and it will put as a group. That is what clustering is. Like, it will take all the similar ones and it will put as a group. I'll show you this example, you can understand, right? See here, it doesn't know the names, it doesn't know this is a bee, it doesn't know this is honey, but it will take all the similar characteristics and it will group. Okay, without any output, it will just group, and it will just randomly name cluster 1 and cluster 2, like group 1 or group 2, something like that. It doesn't have any name, right? So it will just take all those similar ones and it will make a group. That is what is clustering. But in classification, every picture has a name. So when we're classifying, we can easily know what is what. Like bees, all the bees will be in one category, all the honey will be in one category, and all. So this is clustering. And the last one is reinforcement learning. So here, uh, okay, here the agent will interact with the environment, and it will understand, like it will perform some tasks, and based on the tasks it might receive rewards or penalties. Rewards means like positive things, or like penalties may be negative things. Like for example, you can see how we train our pet. Like how you train a pet, if it does the right action, you might give you a treat. If it doesn't, it will not give a treat or something. Or maybe even small kids also, like how we teach them, right? Like if they do something, we might say, okay, this is right, or this is wrong, something like that. Over time, they figure out, like, which actions are good and which actions are not. So machines also can learn in the same way. I'll show you in a very simple example. So we have this robo. Generally these are called as agents. So this agent, there are two options here: a fire and a water. Fire and water. If the robo chooses fire, so it chooses fire, then it will understand something bad happens, right? Okay, fire is bad, it can understand fire is bad. So based on that, the next time it will remember, okay, fire is bad, I should not go near fire. So it will go to water if this has two choices. So this is how reinforcement learning works. Like the agent, the robo, it will keep on learning on its own. We needn't train anything. It just gets rewarded. It just gets rewarded, and based on these rewards and all, it learns the best strategy to win. This is the same idea which is applied in a lot of things like robotics and all. So this is what is reinforcement learning. Did you guys understood what these three types are? If you understood, please put yes in the chat box. Okay, Arish says, can you please repeat this one? Do you want me to repeat about reinforcement learning? Okay, so see, there is some agent. Like you can think of it as a robo or something. So there are two choices, fire or water. Okay. For suppose if it chooses fire, obviously fire is hazardous. It is bad, right? So when it chooses fire, it experiences itself like, okay, fire is bad. It can understand, okay, it hurts the agent or something. I'm giving you a simple example, so please understand. Like the fire is bad, it can understand. When it chooses the fire, it can understand, okay, fire is bad. So it will remember that, okay, like, okay, fire is bad, next time I should not go near fire. Like, you can understand. Maybe small kids or pets also, like when we are in childhood also, we will also have these similar things, right? When you go near fire, you will get like you might get hurt, and then you'll understand, okay, fire is bad. Like this, there are so many choices. I'm showing you a simple example. There's so many other choices also. The agent will, after selecting the choice, if it is rewarded, then okay, it will be like, okay, this is a good one. If not, then it is a bad one. It will remember all these things, and based on these things, it will apply some strategy to attain the goal. Like, see, its goal is to maximize and understand. Like, see, maximize rewards by learning the best strategy. It has to maximize its rewards. When it chooses the right path, then the reward, it will get a reward, right? So it has to make sure it is getting most maximum rewards. Okay, it has to get maximum rewards. So in that way, it will try to get maximum rewards in order to achieve best strategy. Sorry, I said rewards. It will try to get the best strategy to get the maximum rewards. Okay, and it will learn the best strategy. Did you understand, Ayush? Okay. Can you please tell the main difference between three types of machine learning? See, actually, you can't say it is main difference, but what I will say is, in supervised learning, it will learn based on label data. Label data, as I said before, I think you understood, share what is label data. So, if it is label data, then it is supervised learn. If we are giving label data, it is supervised learning. If we are giving unlabeled data, in the sense we are not giving the what output is there for this particular input. See, as you can see in this slide, in unsupervised, we don't know what picture is what. Yes or no? So this kind of unlabeled data, if we give to the machine, then it is unsupervised learning. If we give labeled data, it is what it is supervised learning. And not just these, reinforcement learning is very different from this. In reinforcement learning, the agent learns on its own. We don't need to give anything else. We don't need to give anything. The agent will learn on its own, like the robo or the machine or the system, whatever it is. It will learn on its own. It will only take some decisions. It will only, like, it is very independent. Okay, it is very independent. Here, the supervised and unsupervised learning, what it will do, it will try to derive some patterns or understand some patterns to to predict, to detect something. But in reinforcement learning, the agent will learn on its own. Okay. Did you understand the difference, Shreya? Okay. Okay. So now let us see something. Okay. This is a very important step. This is nothing but how we actually build a machine learning project, like from start to finish. I'll just explain you simply. So the first one is problem definition. See, the very first step is like defining the problem clearly. I mean, you have to understand what is the problem. I mean, you have to understand, right? Like, for example, if let us say we want to detect whether an email is spam or not. So we have to understand it sorry, clearly, right? Completely, right? We are saying we like an email will be there and an email will be received, sorry, an email will be received, and we have to classify it whether it is spam or not. Yes or no? That we need to understand it properly. Like we cannot really say, if we cannot really understand what the problem is, then we can't even build a proper machine learning model, right? Machine learning project. So we have to understand what is the problem clearly. Here we want some spam email detection. So we have to understand that clearly. Means if we give an email, we need to understand, okay, the input will be an email. If we give the email, then the output should be spam or not spam. That is what you need to have. You need to understand. You need to have the you need to have the clarity. Okay. Or maybe if you take a picture, and if you give it to it, maybe it's you are asking whether it is a cat or a dog, something. You need to understand what is the input, what should the machine learning do, and what you want to receive the output. There should be clarity with your problem definition. Okay. So wait, I should that's what is uh, problem definition. And the second step is data collection. Okay. Once the problem is clear, okay, once the problem is clear, the next step is data collection and cleaning. Okay, the next step is data collection and cleaning. uh, Machine learning models will learn from the data, right? So the data is what the most important thing. So if we have like poor data, not like bad data, I'll explain you what is poor and bad. So if we have that kind of data, then the model will not work. Like for example, maybe consider an Excel sheet, or like the data is there. For suppose there is this student information. I think in your college they'll have this information, right? Roll number will be there, name will be there, maybe your percentage will be there, CGPA will be there, something like that, your branch, your section. Okay. Now like there might so what does poor data mean? Like duplicates or error or null values, missing values. Like what is this? Duplicates mean, I'll tell you what duplicate means. When the same kind of information is repeated twice. For suppose a roll number one is there, maybe he is Ram, and Ram Ram is roll number one, and he belongs to CSC, and he's from section one. We suppose. Now again in the second row also, roll number one Ram and CSC and section one is there. Means the same information is repeated again. That is what is duplicate. Okay, that is what is duplicate. And errors in the sense, for suppose in the branch instead of CSC, if it is like 84%, that is an error. That is wrong information, right? That should not be there. And for suppose missing values, the roll number one is there but his name is not there. One is there and the name cell is empty, like nothing is there in that, that is empty. And then the section, the branch is CSC and the section is one. If it is there like this, then it is null value or missing value. Null value or missing value, both are same. So okay, these kind of errors will be there. So we have to clean the data. What cleaning is? For suppose if there is a duplicate row, we have to delete that row. If there is null value, we have to put the relevant information. If we cannot, we can remove that row also. Like if there are these things like row like null values or duplicates or errors, then obviously it will confuse the model, right? it will definitely confuse the model, and because of that, the model cannot predict the future new values properly. Okay, so that's why we need to clean our data, not just collecting it, but we need to make sure our data is nice. Okay, this is the second step, second important step. After that, we have model training. We all gathered the good data, now we move to model training. Now here training, I said you right, training means we the model trying to discover the patterns, which is between input and outputs. That is what is training. So in the spam detection case, what I said, it will detect click here, congratulations, these kind of things, right? So that's what happens in the training, and that's what it learns from the patterns. And in the house price, like sorry, for suppose there is an example like house price or like weather report, something like that, weather prediction also, then it should see how whether the whether whether the temperature is increasing or decreasing, or in the house prices whether the prices are decreasing or increasing. There's some kind of examples like this. So it has to recognize patterns like this. Okay, so it shouldn't see, the model will not memorize it, it will understand the patterns, that's it. Okay, so this is what happens in model training. So this is what simply happens in model training. And then next we have model evaluation. So once the model is trained, like now we have to see properly, right? Okay, whether this is a good model or not, like whether did it properly learn or not. Like we can't just trust the model blindly. For that we'll use something called test data in the sense, when we are giving these examples or when we are like giving the input to the training, we'll take few values and we'll keep that aside. Maybe if there are 10 rows, maybe if there are 10 emails when we are giving for training, we'll give like maybe we'll just give like 7 emails to the model and it will train on that. The other three emails we have, right, we know those are the correct input and output. So if we give that input to the model, then there is some output, right? We can compare that output and this output. Okay, then we can understand, okay, how far is our model good, how far is our model better. Okay, so based on that we can understand it. So that's why evaluation is important. We can understand how far the model is good or not. Okay, so that is what this is. And next, deployment and monitoring. Okay, once we know the model is performing well, if it is not performing well, then we have to use better model, or we have to clean the data better, or maybe we need more data so that it can easily understand more like a accurate pattern. So we need to make sure all those things. And the next step is model deployment. So after developing our model well, if our model is performing well, then we can deploy our app. We can publish our model into the real world so that anybody can use it. Okay, so these are what the main steps. And also after deployment, it doesn't end here. Like there are obviously so many changes happening and the technology is changing and all. Like for suppose there might be hackers or spammers who can detect something in our code or model, and they can find some tricks and do some things. So that's why we need to even monitor also. Monitoring is like monitoring your app, such that if there are any like any bad things or like any wrong things happening, we can change the model, we can change the code, and we can make sure that our model is working fine. Okay, so yeah, let's okay, so for machine learning, Python is mainly used. Okay, for machine learning, Python is mainly used. So why only Python? Because it is easy to learn and read, and it has good libraries and frameworks and all these things. So do all of you have a basic idea of Python? Okay, so since you have basic kind of idea of Python, I think you might understand how easy Python is based like comparing it with C or C++ plus plus or Java or what else other kind of languages. So I think you can understand this, right? And also you can integrate Python in many ways. It is integration friendly. So okay, so Python has two libraries. Those are NumPy and Pandas. And NumPy basically it's like stands for numerical Python or something. It helps us perform fast mathematical operations on arrays, and it is efficient. It is very useful when we are working with large data sets, like which the large data sets are very common in machine learning. So when we use NumPy, we can easily understand it. Like NumPy has arrays in them. Okay, so now you might be thinking, right? Okay, Python already has lists. Then why do we need arrays? So, like, why do we need NumPy? Actually, we can use the lists only, right? If we want to use arrays, we can use the lists only. Why are we using NumPy specifically? You might have gotten that doubt, right? So yeah. So see, Python lists are good for basic tasks. See, they're not like optimized for good mathematical operations or something. See, comparatively, lists are very slower. Lists are very slower, and they cannot. We cannot like they're slower when we're dealing with large amounts of data. They're very slow. We cannot deal large data with them. And list doesn't support mathematical functions. Like see, in machine learning we will not use basic mathematical functions, we will use so many advanced mathematical functions, and all those functions they cannot be used by lists. And also lists are very less in memory efficient, and they're very less in memory less memory efficient. Okay, so that's why NumPy solves all these problems, and it is faster, and like it can do all those things. So that's why NumPy is preferred over Python lists. NumPy arrays are preferred over Python lists. Now let us look at Pandas. Pandas is not exactly like an acronym, but you can think it is like something Python data analysis library or something like that. See, pandas allow us to work with tabular data. What is tabular data? Maybe like an Excel sheet that has rows and columns. Pandas let us deal with rows and columns. Okay, we can see, we can read a CSV file or an Excel file. See, all those things, right? Those are what like be helpful with pandas. See, you cannot easily read those tabular data ba- based on with the help of pandas. You can easily read these kind of lines, and we can explore the data also. There are some methods like dot head, dot info. I'll show you them. And we can also filter, and we can select rows and columns. We can clean missing data, and also we can deal with data when the data is incomplete. As I said before, we have to clean the data, right? We have to make sure there are no duplicate rows, there are no null values, there are no empty cells, those kind of things. We can use pandas to deal with these kind of things. So in short, pandas make it very simple to load, explore, and clean the real world data sets. Okay, so to summarize everything, NumPy is mainly doing math on arrays, and it is fast, it is clean, and Pandas is mainly for tabular data. So together, NumPy and Pandas will help for us in machine learning at all. Like it will help us a lot. Sorry. So I think you understood what is NumPy and Pandas, right? Okay. There's actually I wanted to make you guys do some hands-on. but I think the time is very less. If can you guys can I extend it for like 5 to 10 minutes? Will you do hands on with me? I'll show you some basic uh, NumPy and pandas. How we can do those NumPy and pandas function. Okay, are you guys okay with it? Okay. Um, I think. Okay, let us take a 2 minutes break. Okay, I think I'm telling a lot of information at the same time. So in the meantime, what you guys do is, I think all of you have laptops, right? Or like you have laptops, right? I'll tell you some very basic code. We'll just do it together so you can understand. You can have clarity on it. Okay, you have laptop, right? Okay, what you guys do is go to Google Chrome, open Google Chrome uh, and search for Google Colab. Okay, I think you guys are familiar with Google Colab. I think so. You are familiar with Google Colab. How many of you not know what is Google Colab? Okay, do you guys know Google Colab? Okay, in the meantime, the attendance form is posted in the chat box. So please fill that form. Okay, everybody don't forget to fill the form. Please fill that form immediately right now. All of you fill the form first. First fill the form and then open Google Colab. Did all of you fill the form? Okay, that's your attendance form. It is mandatory, so I want all of you to fill the form. Whoever is attending, please fill the form. Okay, once you fill the form, I think did you guys open Google Colab? If you did, please put yes in the chat box. Okay, I think okay. So are you guys excited to do hands-on? Okay, so let us start the hands-on. Okay, can you guys see this screen, collab screen? Okay, so I think all of you know hello world code, right? Your print hello world. Do you know about that? You know how print works in Python, right? Okay. Okay. One moment. I'll start. Okay. So let us start with I think you guys know print how it works. So in the same way we can print the data and all. Firstly, let us import NumPy. So this is how you will import the NumPy. Can you guys see the code? Okay. So let us, as I said now, uh, we will make NumPy as arrays. Like we'll convert them as arrays. So let us type this. Let us take a variable like variable. Here we are going to use array. So for this, we'll uh, write like this: np dot array of. Okay. So we are going to write like this. We are storing 1 2 3 4 5 like this in numbers as an array, as a numpy array. So you can simply print them and check. Uh, okay. Did you guys did you guys do this? Okay. Now, what we are going to do is we are going to work on with this. See, uh, what makes these arrays different from the lists? Uh, Look at here. First, suppose if we want to add, if we want to perform some, multiply, like addition, like we want to add, a number for each element of the array, we can write like this. Look at here. For each number, the what the addition, the operation is performed. Yes or no? Is the code properly visible to you guys? Okay. So, did you understand this? We can apply the mathematical function to the entire array at a single time, like at the same time. For suppose we are using lists, then we have to use a for loop. We have to iterate. We have to do like that, right? But for when we are using arrays, we don't need to do that. When we are using NumPy arrays, we don't need to do that. In the same way, we can apply multiplication, or we can do mean, or standard deviation, all these kind of things. Like you can do all these kind of things for the NumPy array. Okay. uh, for suppose we want to generate not generate, like we want to store. Maybe we'll take one more example. We want to print some zeros. Okay, we want to print zeros. We want to print some like maybe 5 zeros or 10 zeros. We needn't store all those zeros. We can just use this kind of function. We can use this kind of method, which is like this. See here you can see these 5 zeros are stored in an array, NumPy array. We can see, we can make the array like this, array of 5 zeros, using this method. Did you guys understand this? Okay. uh, we can also we can also generate random numbers by using a random method. And we can also do something like these. Okay, and for the indexing part, how it happens in the list, it happens in the same way here also. For suppose we want to print the first element of array in numbers, the array numbers. This is how we do for the list, right? We can also do the same thing for array, NumPy array. See, we can also do the same one, right? We can the same kind of indexing will work. The same kind of indexing, list indexing, will work for the NumPy array. Okay, this is some basics about the NumPy array. Uh, I'll tell you about pandas also. For pandas, you will import like this. I think you know what as means. Here, you know what as means, alias, right? You can actually directly import. You can directly import pandas. You can just say import pandas, and you can use pandas dot something something. Like for the NumPy also, import NumPy as NP. You can here just simply write NumPy dot array. But if you put alias, you can understand it as NP. You can just use the NP. It will reduce the complexity, like the burden of us typing again and again the same word. So pandas, as I said, pandas is like it is like tabular data. So for suppose how this works. After importing pandas, what we'll work on with fruits. Fruits is equal to pd dot. We'll use a method called series. Okay, we'll use a method called series where we can give each a value. Like for suppose here I'm giving apple, and then I'm giving okay, apple, some banana, and mango. I gave some values like this, right? Okay. So what here we are storing in series, right? So we'll see how this is stored. We'll print fruits. Okay, we are printing fruits. Look at here. You can see this is a tabular data, right? By default, these values are there, right? These values by default they are in that order, or otherwise we can actually keep some column names and row names also. I'll say that also, but we'll use series for this kind of data. And there is another thing called data frame. For this data frame we can use columns, and we can have some rows and columns. I'll show you that. Data equals to, I think you might be like, see, I'll tell you it. So okay, this is the column name. Okay, this is the column name. Okay, and this is the name of mm, this is the row name. Like for row, for first row, this value is there under name, and you can have another one also, age. This is another new column. So the columns are stored like this. Okay, the columns are stored like this. You're creating some data frame, and age for suppose is like 19. Okay, wait, here you have to put a comma. You have to put a comma after each column one. You can put the comma here also. Maybe maybe CGPA, we will add CGPA. And again you have to open the square brackets for each individual value. Okay, maybe she got like some 8.5. For the last column you needn't put a comma afterwards. Now we'll what we have to do is, this is how we are storing the data in data. Now we have to convert this to a data frame that can be converted like this. You can just put pd dot data frame. Now you can simply print df. So you can see, right, there is a table kind of thing. You can add new values also, like this. You can add the new values. See, now a new row is formed. Are you guys understanding this, or am I being too fast? Are you guys doing along with me? Are you guys typing the code in your collab? So this is how you can make like the thing. Now I'll just say you just few functions. I'll and wind up the session. Just stay with me for 2-3 minutes. That's it. I'll just tell you few things. So now this is how data is stored, right? How can we use it for our like machine learning things? See, first suppose, sorry, it's in caps. Print, you can use head function. Head, this one will help you, head method will help you to display the top things of the uh, like the top 5 rows. It will give you top 5 rows. First suppose if there are like more than 5 rows, first suppose let us give more than 5 rows. I'm just giving more than 5 rows so that you'll understand what a head does. We are just giving random values. So, see now there are 7 rows, right? There's 7 rows. But when I use head, only the top 5 rows will be displayed. Okay. This is what a head method does. Okay. Then you can also display the column. So df, just how you do for indexing, you will give the index value. Here you will give the column value. If I give you the if I give the column value in this, see, all the names will be printed. All the names. These are the names, right? All the names will be printed. Okay. So, and also there are some other functions also, like you can even sort the values. For suppose here we have age, right? We can use this method, sort values. Okay. And in that, you will give the column name. You will give the column name. Sorry, 1 minute. You will get the okay, wait, I didn't have this thing. You'll the age will be sorted. Um, I put it. Okay, I missed an S here. That's the mistake. Okay, I missed an S here. It is sort underscore values, and it will see. You can see here the values of the age are sorted. We can do all these kind of methods. Okay, we can do all these kind of methods when we are cleaning the data. Okay, when we are cleaning the data, we can see use all these kind of data. And I'll tell you one last one. One last one. If I want to know, see the ones who are like I want to put down a condition, I can use this. About 19. See, only the ones who are above 19 are displayed. So we put some condition here, right? We put some condition, and according to that condition, the values are sorted. So we can perform these kind of methods, and such that uh, we have tabular data, right? The tabular data we can perform data cleaning, those kind of things using this. Okay. So so this is what this is for today. I think I hope all of you got clarity on what what is the introduction of machine learning and about numpys and pandas, right? Do you guys have any doubts for today's session? Do you guys have any doubts? I think I extended a lot. I think I extended for almost 20 minutes. Um, I think it's okay for you. I think, um, can you show the last code? This one? Okay, this is for the condition. Yeah. Okay, somebody has a doubt for reinforcement learning. Okay, what kind of which type of algorithms are used? And like see, there are actually some complex type of algorithms. I'll discuss about those in the last day, maybe on the day which on the day when I'm discussing reinforcement learning. See, there are like policy based kind of things. See, what I said, they get their rewards, right? Based on that, there are some methods like, I'll tell you about those in the reinforcement learning, then you can understand them. Okay. I think there's some policy based, value based, there are some things like that. Okay, I'll tell you about them in the next upcoming sessions. Is it okay? Is it okay, Rani? Okay. If anybody have any doubts, they can ask me. If not, then you can leave the session. Thank you for joining the session. That's it for day one. I hope all of you will join for day two. We'll continue with supervised learning tomorrow, and we'll do classification. Okay. Anybody have any doubts? If anybody have any doubts, you can stay. Otherwise, you can leave. Don't forget to attend tomorrow's session. Okay. Okay, guys. Thank you. Bye.